In this video, we'll take a quick look at a Wireshark packet capture of onboarding a 3PCC phone to WebEx calling. We'll specifically analyze the packets as the phone does an onboarding to WebEx calling. I will register the phone using the activation code, and then we'll make a quick test call. The key thing is we'll be viewing specifically what source destination IP addresses are used. On the private side, it will be a RFC 1918 address space for the phone. I'll show you in a moment. And then on the public side, we'll see the variety of different public IP addresses that the phone is going to communicate with. So what we're going to start off with is I will concurrently do a factory reset of the phone, and then at the same time we'll start a packet capture here. So if you notice, the filter I'm using is a MAC address space filter, part of the MAC address I'm blurring for obvious reasons. This is an effort we can focus on a packet specifically related to this phone. So I'm going to concurrently delete and then start the packet capture. Okay. So what I just did is I just did a delete from WebEx calling of the phone. And then what we want to do here is we want to go under conversations. We want to go under IPv4. And then we want to take a look at the conversations that's going to be occurring. The phone itself is going to be the .78 IP address 192.168.1.78. So right now it's going through a factory reset. And basically we want to take a look at the communications the phone is having. So one of the items that we'll see is going to be DNS activity. And then there's going to be a list of different communications that the phone has with resources in the cloud. One of the documents that's key to view if you're needing to troubleshoot and or make adjustments to your security devices such as firewalls is going to be the WebEx calling port usage document. Okay, so the phone just rebooted. It's doing a configuration check in progress. This will take a few minutes. And what I'm going to do is I'm going to prepare to generate an activation code for the phone. So while the phone is getting up to the point where it is going to offer a activation code option to be entered within WebEx Control Hub, I'm actually going to generate a activation code for this phone. The phone, by the way, that we're testing with is a 8841 phone, 3PCC. Okay, so the phone is asking me for an activation code. I've just generated an activation code. I'm entering in the activation code right now to the phone. Okay, I'm just going to verify that the activation code matches 100%. Okay, it looks good. I'm going to hit continue. Okay, it's saying connection in progress. Okay, gave me a green check mark. Accepted the activation code, download in progress. And if you notice, there's quite a lot more communication starting to develop on the phone right now. The phone that I'm testing with does not need any firmware upgrades. It's already in parity with the firmware that is currently being used on WebEx calling, which is 12.0.4.SR1. Be aware if you have a phone with older firmware, there may be quite a bit more activity and or amount of time that it takes to onboard the phone because of firmware upgrades. So again, this phone, all I did was took a phone that was already with parity on the firmware that WebEx calling is using. I went ahead and deleted it from WebEx calling, at which point the phone was factory reset, and this is what we're seeing right now. Okay, so the phone just onboarded to WebEx calling. Let me go ahead and do a quick test call to another phone. Okay, so let me pick this up on the other phone. Testing. testing, testing, testing. Okay. So what we can look at is we can also look at the UDP traffic, because when we're doing actual calls, there's going to be UDP traffic. Testing, 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 testing. So we should see updates if you notice the packets right here for UDP. It's going to be the voice traffic right there. And then if we look at the TCP, TCP obviously is going to be, let me go ahead and hang up this call. TCP is going to be obviously related to the SIP protocol and any other communications or management. Most of the traffic will be encrypted. So let me do this right now. Let me go ahead and stop the capture here. And then we'll go ahead and take a quick look at a couple things. So I'm going to go ahead and stop the capture. And then let's go back here to the communication side. So from a general communications DNS, and then generally what I like to do is I like to look at the IP addresses that the phone is communicating with. I'll use the WebEx calling port usage document as one of my references, and generally I'll put in the first 3 octets, or if it's a larger subnet, maybe the first 2 octets, and just see what is the phone, what services is it trying to access for those specific subnets. The other one is also ARIN, the Authority for North American Internet Numbers, because some of the services may be hosted in AWS, and thus there may not be a specific static public IP address range that's allocated to those services. So generally speaking, those are the 2 different reference points I use. The other reference obviously is if you're having a problem deploying a phone within a specific network, if you can take the phone with you to your home network and do a Wireshark capture and also debug level PRT after the phone is deployed, to use that as a reference. And then if you take the phone back to the company or the location that's having issues, then you can do a comparative analysis. What is the difference? Because at that point in time, when you plug the phone back into the network that was having issues, since we know the phone's already registered to WebEx calling, does it function or not? If it functions, then you can do another test by deleting the phone from WebEx calling and having it try to register again at that site, since by that point of time you have a PCAP already generated, kind of what I'm showing here, and also perhaps you've generated a debug level PRT. So just to kind of take a look at this, so this is kind of at the top right here. This is when it factory reset DHCP request. We have DNS requests here. This phase right here, I believe, was during the actual reset that I was doing from WebEx calling, where it was sending commands down to the phone. But in any case, you can stop the video at any point of time to see kind of from an IP address standpoint what is being seen. Then from a TCP standpoint, there's quite a lot of activity here, so I'll kind of go down the list here so you can take a look at the ports. So a lot of usage of port 443, and then also port 8934. And if you look at the WebEx calling port usage reference document, you notice the same type of references are made as far as what port usage is being leveraged. And then if we go to UDP, which would mainly be related to VoIP traffic, the RTP or encrypted RTP traffic. So here if we take a look at the ports, so 23,472, and then these are generally much larger port ranges when you look at the port usage reference document for WebEx calling as far as what is being used. So let me go back here and let's just take a look here at TLS. You can kind of get a general idea, and then what I'll do is I'll do a OR DHCP or DNS. And we can kind of see the life cycle. So initially the phone was registered to WebEx calling, and then I deleted it from Control Hub. And that's when the phone got instructions, okay, go ahead and factory reset yourself and reboot. And that's kind of what we're seeing in this phase right here, where it's going to do kind of a DHCP release, and then it's going to do some DNS transactions here, and then it's going to start with the onboarding process as we kind of go down the list here. So actually, here we go. So this is where it's asking for DHCP discovery request. It's going to get a IP address, and then it's going to start doing a bunch of different DNS queries, kind of what we're seeing here. And I'm going to adjust my column here for the info so we see a little bit more here in the info column. Okay. Okay. So let me go down the list here just so you can kind of get a general idea what is happening right here. Okay, so we have some TLS starting at this point of time. So what you will notice, other than initial, handshake and, DHCP and DNS, most of the other traffic is going to be encrypted. So when you're troubleshooting, often you will be focusing on IP addresses, specific public IP addresses or domains based upon the port usage reference document for WebEx calling. And also, other than that, also, is there any issues? One example would be if the phone is trying to make a TCP connection outbound, nothing's coming back, it's retrying, nothing's coming back. Definitely that could be an issue where something is blocking it. The other scenario could be there could be an issue related to fragmentation and or MTU and or TCP maximum segment size. Something's not quite right. So by the time the packet's trying to reach the other side, it's either being dropped or it's not being, the fragmentation part is not working correctly, or the at a layer 4, the TCP maximum segment size, something's not quite right. So those are all elements that one should look at. Again, very basic test. If you're having issues, take one of the phones with you home. Try to do an onboarding at home. If you can do a Wireshark capture, highly advisable. Once it's on board, you can go in and generate debug level PRT. Obviously, during the onboarding phase, the initial phase, there will be nothing logged because the phone is booting up from a factory reset. But in later phases, the debug level PRT can offer some good information, especially if you're running into issues with licensing or the phone is not fully functioning, meaning it's somewhat registered, but not everything's functioning, where you might have it register from SIP standpoint, session initiation protocol, but then from a WebEx aware standpoint, it's not quite there correctly where the cloud is on the top right corner of the phone. So in any case, let me go down the list here so you can kind of see what a working scenario looks like. And you'll notice there's a lot of DNS, a lot of TLS encrypted connections are going on. You can also look at the column here, the length column, which is the actual size of the packets. So again, that's another area I would kind of focus on, because I have seen scenarios where folks have spent a good amount of time ensuring from a security standpoint, their firewalls and or any other security devices they have, they're not blocking, but then the issue ends up being in a pathway from a fragmentation standpoint, layer 3, layer 4, something's not quite right. Or the other thing is something in the pathway doesn't like the fact that packets are being fragmented, if you will. So it can be something from a size standpoint of the packet, MTU size, and or TCP maximum segment size, and or fragmenting. So those are some vector points to keep in mind when analyzing and troubleshooting. So we'll just kind of continue down the list right here, kind of use this as a reference. And the pattern really is right now mostly TLS, but you will see DNS traffic at times. A lot of the services in the cloud is load balanced, and or geolocation can definitely influence what data center or data centers that the phone may be leveraging. So you often will see quite a lot of recurring of DNS and the phone trying to access different type of services or servers in the cloud. And we'll kind of just head towards the bottom, see if there's anything else here that we can consider. Yeah, actually, let me do this. Let me go ahead and let me type in UDP. Let's for a moment look at the RTP traffic here. So if we go in here, so let's go down the list. So I did make a phone call at the very end there. Okay, so one of the things that's a little bit tricky is when we're dealing with encrypted traffic, Wireshark typically by default won't be able to identify it as being RTP type of traffic since it's encrypted. Unlike if it was unencrypted, generally you would be pretty good shape of it identifying. One of the tattletale signs is you'll typically see at least one of the directions the packet's marked with EF, expedited forwarding. So that's one tattletale sign. There's a bunch of these packets. They're UDP. And then if we go down here, we're going to see a bidirectional, which, you know, full duplex communications, which is typically, you know, your normal phone call. So what we can do is we can select one of these packets. We can right click and we can go decode as. And then here what we can do is we can go ahead and type in RTP. We can go ahead and hit OK here. And what you notice now it looks much more familiar what we're used to here as far as we have information regarding its RTP packets. So now if we like, we can go up to RTP and we can go to streams and we can actually see some information about the RTP packet here. So for example, I can grab this guy right here. This is a public IP address. And then actually, let me go down to analyze. We'll give this a moment. And then this can give us some statistics about this packet. We won't be able to play back the audio. It is encrypted, but at least we can look at the header information and use this kind of as a vector point for analyzing if there's any type of troubleshooting you need to look at. The one thing to be aware is even if this was not encrypted, historically Wireshark sometimes has been unstable when working with RTP traffic, especially if it's a larger PCAP. So just be aware when you get into this dissector function, you may want to kind of go at a slower pace and try not to click on too many things too quickly, I guess. Let me see if there's anything else here of interest we can look at. And then we'll go to the packet links. As I was mentioning, I would just keep an eye on the size of the packets. If you're seeing a situation where you're hitting a large packet, a large TCP packet, and then it's struggling, so let me do this. Let me go length. Let me resort this. Just as a note, there's no issues in this example. So this is like a fully working example, no issues. If it was struggling, yeah, I'm just looking at the packet links. There's nothing here of any significant size. But normally what you would see is you would see a TCP connection. And you know what, actually, let me change this. So normally what you see is a TCP connection of a larger size. And then you would see a retransmit occur. So if you notice, our largest packets are 1434 packet size. You know, not bad whatsoever. But you may get in scenarios where it will start hitting, you know, 1500s. Sometimes may even go a little bit higher than that. And what you may see is, you know, it trying to transmit, like the phone trying to transmit out, and nothing comes back. Then tries to transmit out, nothing comes back. So this would not be a good example. Thinking of it. But in any case, I would just keep an eye on the larger packets. If it's sending out and nothing's coming back, that would definitely be one item to take a look at. And let me see if there's anything else here of consideration. So this is where we were actually doing the conversation, the test call, if you will. So if you notice packets per second, it's in the low 100s. Generally speaking, bandwidth usage-wise, VoIP itself is not too bad. Depending on the codec, if it's just a G.711 ULAW or ALAW, generally it would be in the 80-something kilobits per second usage as far as the bandwidth goes. If you get in video, it depends on the actual video endpoint, But generally, I would say definitely you should be anticipating, a couple hundred kilobits per second, generally probably more towards the 500 plus kilobits per second, but it really depends on the resolution codec. Are we talking about H.264, H.265? Their standard profile, high profile, resolution, also the content of the video image itself, if it's complex, basic, is there movement, etc., etc. So in any case, hopefully this kind of gives you a general idea if you're doing onboarding to WebEx calling and you're running into issue with 3PCC phone, something you can actually look at to get some evidence of what might be occurring, and then use that as a vector point and compare that information to the port usage document that is offered for WebEx calling. Thank you for watching this video. Hopefully it helps. Thank you.